So today we're going to go in the opposite direction. Yesterday we went from rectangular to polar coordinates. Today we're going to convert from polar to rectangular. So whereas our equations have r and theta, we're going to convert them to equations having x and y. All right, so take a look at the first one. We have theta equals pi over 4. Now, before we get there, remember our bridges, right, between the two worlds. One is x is r cosine theta, y is r sine theta. That's how x and y are related to r and theta. Another relationship, another bridge between the two worlds is that tangent of theta is y over x. So we are free to use any one of those relationships as we see fit. Okay, now here I have theta equals pi over 4. And I want to get rid of the theta. In its place, introduce x and y. Okay? So when I look at here, the one with the most direct relationship from theta to x and y is the tangent, right? It directly relates theta to x and y. The difference is here it's tangent of theta, and in this problem, theta equals pi over 4, there is not a tangent anywhere to be seen. Okay? So now, before we do that, let's think about theta equals pi over 4. What does the graph of that look like? Yeah. It's a straight line, right? At theta equals pi over 4. So we want this, we would rather this had a tangent. But you know, in math, you can do anything to an equation as long as it's mathematically viable. All right? Remember with exponential functions, you can take the logarithm of both sides? Well, with this, you can take the tangent of both sides. All right? So why don't we do that? Why don't we take tangent of both sides. Yeah, hang on. So we're going to take the tangent of both sides. So it's going to be tangent of theta is equal to tangent of pi over 4. That's all I did. Now, Eli says tangent of pi over 4 is 1. What's tangent of theta in our world? Y over x. You see what I did? I worked on each side independently, right? Y over x is equal to 1. Like tangent of theta is y over x from that identity. Tangent of pi over 4 is 1. Now look at that. Magically, all thetas are gone. Can I solve this equation for y now? Y equals x. What kind of graph does that give me?
Origin.
A diagonal line, right? So if I were to graph this, y equals x, how much is that angle? 45 degrees. Is that like theta equals pi over 4? Right. You see that? Had I graphed theta equals pi over 4, that's what it would have looked like. How magical is that? Right? Y equals x, theta equals pi over 4. So you see what we did is we took the tangent of both sides. All right. Now here we have r equals 7. Okay? All right. R is fine and all. What does r equals 7 look like? What does that graph look like? It's a circle. How does an equation of a circle in rectangular coordinates look?
Y squared plus x squared.
X squared plus y squared.
Equals r.
Okay, r squared equals r squared. X squared plus y squared equals r squared. Why am I even thinking about this? Because from here, I know that this is a circle, which makes me think, oh, x squared plus y squared equals r squared, right? So do you see the rationale? I have this problem on my paper, r equals 7. That's a circle. Circle, x squared plus y squared equals r squared. Okay, I have r, I need r squared. Oh my God, what to do? What to do? What do you think? You can square, you can't just square one thing, you have to square both sides. All right, so square both sides. So r squared equals 49, but what is r squared really? X squared plus y squared. equals 49.
That's it?
That's it. And all of a sudden now,
Yeah, how'd you get from? Wait, what?
okay, let's do it again. Okay. Is everybody okay with this? Is everybody okay with this?
Yeah.
Okay. Now, yesterday, here, remember what did we say here yesterday? Where was it? Here. Remember we said r squared is x squared plus y squared because of the Pythagorean theorem here, right? So that's another thing. R squared is equal to x squared plus y squared. So you know what? Maybe we could add that to our list of equations here. R squared is equal to x squared plus y squared. So now when I have r squared equals 49 here, I say, oh, but r squared, that's the same as x squared plus y squared. That's the bridge to go from polar world to rectangular world, right? Equals 49, and guess what? You're done. Because what is it that you have here? You have a circle with radius what? 7. What did you have up here? Circle with radius 7. All right? Okay. What is this? What is this an equation of? R equals, yeah. It's a circle.
It's facing down.
It's facing down. What's the diameter?
5.
5. Right? That's what it is. Okay, so this is a circle. So again, I need, x squared plus y squared business, right? Okay, now, like I said yesterday, I put on here one example of each type of problem you are likely to see. Each one has their own tips and tricks, and you don't know how to do it until somebody teaches you how to do it. And then every time you see a problem, you're like, wait, have I solved one that looks like this? What did we do there? Okay, let me do the same thing here. So the thing to do here is I have r, and then I've got sine theta. To get rid of sine theta, what I need it to look like is r sine theta. Then I could make it a y. Okay? So now I'm like, okay, God, if I could only make that an r sine theta. So I'm like, okay, maybe I could just multiply that by r. And wait, let me multiply that by r as well. And then I'm like, wait a minute. When I do that, I get r squared, which is always a good thing, right? So why don't we do that? R squared is equal to negative 5r sine theta. But what is r squared? Because to get rid of the sine of theta, it should look like r sine theta, right? So you could, it doesn't matter. It was just sine theta. Now we added an r to it. So now look at what will happen. It's negative 5 times r sine theta, which is y. Okay? Now, I know. Now let's bring everything to the same side, because normally this is how it's written. Believe it or not, this is where this ends. But I know you don't believe me. So you know what? Let's do a little bit more here. You guys remember this thing called completing the square? Yeah. Let's complete the square on this and see where it takes us. X squared plus y squared plus 5y is equal to 0. When we completed the square, what we did is we grouped all the x's together and we grouped all the y's together. So now this is going to be x squared plus, and let's group all the y's together. But remember, the whole point of completing the square was plus a number equals plus a number. You remember that? So here it's going to be 0 plus a number. Who remembers how we got the number that went in that blank?
Well, you had to know.
Elliot.
It's half of c squared.
Half of b squared. It's half of this number squared. So half of that number is 5 over 2, which is 2.5, squared, 6.25. And the whole reason why we do this is because we want to complete a square. We want it to be a square, which we can factor in squared form. And let's just factor that now. This is x squared plus, when I factor this, I get y plus 2.5 squared equals 6.25. Now, you tell me what that looks like. X squared plus y squared equals something squared. This is now an equation of a circle. But what's happened to this equation of the circle? It shifted down. So compared to x squared plus y squared equals r squared, now I have y plus 2.5 equals 0. So it's shifted down by 2.5. And what's the radius? Nope. 2.5. Look. The center has shifted down 2.5 units. The radius is 2.5. The diameter is 5. It's exactly what we got from there. Isn't that cool? Like, come on, that's so cool. It can't get cooler than that. So now, you don't really have to do this for me. It's fine if you stop there. I only did it because if I told you a million times that this is the equation of a circle, you wouldn't believe me, but now you see that it is, okay? So it's fine if you stop there. Just recognize that that's an equation of a circle. Yes, we'll do some homework. Yes? Remember I said that I only did half of 10.1 and I said I was going to do a little bit from 10.1 here. Well, here it is now. Polar distance. You know how we calculate distance in rectangular coordinates? X squared, right. x2 minus x1 equals blah, blah, blah. You could also do the same thing with polar coordinates. We just have to now derive that formula here. For this, I need, we're going to have to use an identity, so I just want to remind ourselves, remember that identity? Cosine alpha minus beta, what was it? Cosine minus sine, right, okay? We're going to use that later, so let's just keep it here. Okay. All right, so let's do this. Suppose I have a point here, okay, x1, y1, I'll call that P1. And then suppose I have another point here. All right? And now suppose I wanted the distance between these 2 points. In Cartesian coordinates, what is that distance? It's the, right, it's the square root of x2 minus x1 squared minus y2 minus y1 squared. Plus, I'm sorry. You remember that? Back in the day. Okay, now, we want to do that. Now I want to find the distance, but with polar coordinates. So no more x and y. So in rectangular coordinates, I find that point by x, y. That's how I describe that point, right? X, y. In polar coordinates, to describe that point, I need r and theta. So basically, this is r. I'll call it r1. And this is theta 1. Okay? So that's how I can go to that point. I go a distance r, and then I rotate an angle of theta, okay? To describe that other point, it's r2, and then theta 2. It does start from the origin, right? So r2 goes from the origin to the point 2, and then you go an angle of theta 2. So now I have theta 1. It goes from the x-axis to the blue radius. Theta 2 from the x-axis to the green radius. If we wanted to describe the angle in between, right? That angle there. How big is that angle? In terms of theta 1 and theta 2, how much is this? Just that one. Huh? Not 90. So, okay. So if it's theta 1 from the purple to the blue, if it's theta 2 from the purple to the green, what's the balance? Theta 1 minus theta 2, right? So theta is equal to theta 1 minus theta 2, right? That's that angle. Okay? All right. So I have this formula for the distance in rectangular coordinates. Can I convert that to polar coordinates? Of course I can. Because x1 is r1 cosine theta 1, right? And what's y? R sine theta. But if it's y2, then it'll be r2 theta 2. Wait, no, sorry. I want to call that y1. x1, y1. So y1 is r1 sine theta 1. So then for the 2's, x is r cosine theta, y is r sine theta, but x2 will be r2 theta 2, y2 will be r2 theta 2. Okay? We're going to derive this formula now. So now, I'm going to rewrite that. I'm going to need some space, write small. I have x2, which is r2 cosine theta 2 minus x1 squared plus y2 minus y1 squared. Okay? Now you know what I'm going to do? Square everything. So remember when we square a binomial, it's the first term squared, 2 times these, and then the last term squared. So when I square the first term, I get r2 squared cosine squared theta 2 minus 2 all right, we'll do it this way. R1, R2, cosine theta 1, cosine theta 2. Plus R1 squared, cosine squared theta 1. So that was just squaring the first parenthesis. Now let's square the second. R2 squared, sine squared theta 2 minus 2r1 r2 sine theta 1 sine theta 2 plus r1 squared sine squared theta 1. Okay? Okay, so now look at what I have here. D equals, okay, the square root of, okay, I'm going to collect all the ones that look like this. Look, R2 squared, R2 squared. So that's going to be, okay, look at what I have. R2 squared, cosine squared, plus sine squared. Can I just factor out the R2 squared in one step? So I'm going to do R2 squared cosine squared theta 2 plus sine squared theta 2. You see what I did? No? I pulled out the R squared. Now I'm going to do the same thing with the R1 squared. Yep, so much work. R1 squared cosine squared theta 1 plus sine squared theta 1 And then what do we have left over? Look at what I have left over. Minus 2R1, R2, this stuff, minus 2R1, R2, that stuff. What can I factor out of the green ones? Minus 2, R1, R2, cosine theta 1, cosine theta 2, plus sine theta 1, sine theta 2.
Which is cosine.
Oh my, look at that. That's an identity. Okay, so let's go slow here. D equals, hey guys, what's this in the red parenthesis? Sine squared something plus cosine squared the same thing? It's just 1. Sine squared theta plus cosine squared theta is just 1. So that becomes a 1, and now I just have R2 squared. And what's this thing in the blue?
R1 squared.
Plus R1 squared, because that's just a 1. Now, minus 2R1, R2.
And then you can, it's cosine A minus B.
Look at what I have here. Sine A, sine B, plus cosine A, cosine B, or cosine, cosine, sine, sine.
Yeah,
Right? Cosine, cosine, sine, sine. Cosine, cosine, sine, sine. What is that?
It's cosine A plus B. Minus.
Right. No, it's plus. This was a plus here, so they have opposite sign. If this is a plus, then it's got to be a minus.
So cosine theta 1 minus theta 2.
Cosine theta 1 minus theta 2. And now, believe it or not, we're done. But let's just see what we have done. Let's just see what we've done. The distance in polar coordinates is, look, R1 squared plus R2 squared minus 2R1, R2 cosine of theta 1 minus theta 2. What's theta 1 minus theta 2? The angle in between. Right? That's the angle in between. So it's R1 squared plus R2 squared minus 2R1, R2 cosine of the angle in between. What does that remind you of? Where have you seen that before? I'll tell you later. Okay, so that's how you find distance between, I'll tell you later. That's how you find distance between two polar points. So take a look here for a minute. An air traffic controller is tracking two airplanes flying at the same altitude, right? The coordinates of the planes are 8 and 60 degrees, so we're going to go by 2's. So that's plane A. And B is at 4 and 300. Okay? So this is R1, and this is R2. All right? So it says sketch a graph of the situation, which we've done. The directed distance is measured in miles. Directed distance meaning, you know, just like that bird's eye view. Okay? So sketch a graph, which we just did. How far apart are the two airplanes? Well, for that, we need to do the distance formula. So that's going to be R1 squared. Don't pull out your calculators just yet. R1 squared, which is 8 squared, plus R2 squared, which is 4 squared, minus 2 R1, R2, cosine 1 minus 2. So 60 minus 300. Okay, I have a question for you. What if I did 300 minus 60? Why?
Because even if you get a negative, even if you get a negative answer, the cosine of that negative answer is still going to be the same. Because cosine of pi will be the same as cosine of negative pi.
That's it. Cosine is an even function. So if I did cosine of 60 minus 300, I get cosine of negative 240. But had I done it reversed, 300 minus 60, I would have gotten cosine of 240. Same thing because cosine is an even function. Okay, so now I have D equals, this is 64 plus 16, which is 80. Minus 64 cosine. Right, and I just write 240, right? So D equals 80 minus 64. Okay, so now cosine of 240. This is a 60-degree angle. So suppose this is on a non-calculator section. This is a 60-degree reference angle, correct? What's cosine of 60? 1/2? 1/2? But if it's 240, right, where does 240 sit? On that side, on the left side, so that's negative. So that's the square root of 80 plus 32, the square root of 112 miles. Okay, so if it's a non-calculator section, you would have to put it in simplified radical form. If it's on the calculator section, you can just plug it into your calculator. Yeah. And what did you get? 10.6? It sounds about. And the square root of 112, what was it? Eli, what did you say? 10.6. Okay? All right, so let me stop graph. Okay. So if I wanted to graph, let's say this one, right? R equals negative 4 cosine theta, it's just the same as, graphing anything else. Once you're in this, so again, in order to go here, once you have your graph, you have to go to menu, number 3, and then number 5 for polar coordinates, okay? And here you could put in anything that you want. So negative 4 cosine theta is in here. You see that pi symbol on the left bottom corner-ish, okay? In that pi menu, there's all your wonderful, lovely symbols, including theta. And then when you press enter, that's your lovely little circle, okay? And so now.
So what's that other thing below it?
Which other thing below it? Okay, this stuff. You mean this stuff? Okay, so what that says is this is graphing from 0 to 6.28. 0 to 2 pi. So listen. So do you remember when we were doing this? Where is it? Remember when we were doing this? We were plotting points from 0 to 2 pi, and then we said if you went further than 2 pi, then it would just retrace the curve over and over and over again. So that's what it's doing. It's graphing from 0 to 2 pi. Now, if you told it, hang on. If you told it to go, let's say, from 0 to 3.14, then what it would do in this case, is just graph 1/2 of it. Okay, so let's try that. This is 2 plus 4 cosine theta. So let's do that. It's 2 plus 4 cosine theta. And here I just want to go from 0 to 3.14. You see that? It only graphs half of the limicin for you. Okay? So look at what I did. Tab. I did, come on now. So I put in this thing, and I went only from 0 to 3.14, and it only graphed half of the limicin for me. So now if I wanted to go back to 6.28, it would graph the entire thing for me. Okay? And what the step is when you're tracing it, As you go up here, the theta changes as like 0.13, okay? Like, and all the way from 0 to 6.28. Okay, so you know what? Let's graph in here. Give me one more second. Hang on. Give me one more second. Here, let's graph. Okay, so let's graph this one. The last one here. Tangent theta, secant theta. So let's go back there. And I want to graph tangent theta, secant theta.
The whole thing or just like the 3.14?
To 6.28. Graph it, look at that. How cool is that? Right? That's super, super cool. That's that parabola that we were graphing before, right? In rectangular coordinates, remember it was y equals x squared, and look at that, it's a perfect y equals x squared, but it's tangent theta, secant theta. Okay? Yeah.
What's that other thing that says theta step equals?
Okay, so that's what I was talking about.